about Zafran. I'm from class F, 1F, and I'm from Faculty of Chemical Engineering.
My name is Aira binti Faizal from class 1F, and I am from Faculty of Chemical Engineering.
My name is Qasdina. I'm from 1F and Faculty Chemical Engineering.
My name is Sahira. I'm from 1F from Faculty Chemical Engineering.
Function. Analysis function is a technique used to identify and understand the needs of the project, product, or service. Other than that, analysis function is an essential component of value engineering or value analysis process. Next, why we use analysis of function? We use analysis of function to support creative problem solving by moving the focus away from the expected solution. Other than that, we're placing the focus on the required performance or need. Explain to you guys how to answer a question. Given a function fx equal to negative x power of 3 plus 6x power of 2 minus 9x. For this question, we need to find the y-intercept of f. So basically, y-intercept is x equal to 0. First, we copy the equation. Then, we replace x with 0. We will do the calculation and we will get the answer is 0. So, y-intercept is at the point 0, 0.
The first step of the function we use is fs negative x power 3 plus 6x power 2 negative 9x. The function, we can find the critical point. First step, copy the function. With the function, we need to do the differentiation. So the answer is negative 3x power 2 plus 12x negative 9 after differentiation. Then fs need to be replaced by 0. So the first x we get 3 and second x we can get 1. Enter x to the function negative 1 power 3 plus 6 y power 2 negative x y negative 9 1. So we can get negative 4. For second x, negative 3 power 3 plus 6 3 power 2 negative 9 3. And we can get a 0. So, critical point, we can get 1, negative 4, and 3, 0. Okay, that's all for me. Thank you.
Okay, Bismillahirrahmanirrahim. My name is Zafran. So here, I will explaining about this question. Find the interval where the increasing or decreasing. Hence, find the extremum. Means we need to find maximum point and minimum point if of f, if any. Okay, so first, the first step is derive the equation. So you derive from the main equation, the function, then you derive, you get this. Then you need to find x. How you find x? You need to use quadratic equation. Then you make the critical line. This is step 3. Okay, you need to make critical line to determine whether 3 is negative, 3 is first, or the 1 is first. Okay, then you need to do this table. So then you need to determine the interval by using this critical line. Then you use the test value. The test value, how you want to find? You need to find by the critical line. So 1 is more to the negative. 1 is for the negative infinity. So the test value need to be in that range. Same for others. So when you choose the test value, you need to insert that test value in the equation that you just derive. This one. Then you need to find either is positive or negative, and then you need to write what is the decreasing interval, increasing interval. So then you get the mark here, and then you need to find the extremum. So you need to find the minimum point and maximum point. So maximum point here, how you want to find? You need to use the function, and then you enter the value x3 by how you find the x3. You by this one. You insert the 3 inside the function, same as the minimum point. So then we go to the next question. Okay, here is very easy. So here you get 2 marks. So here is the second question. Find the interval whether it's a concave up or the concave down, and find the inflection point if any. So how you find the how you want to find the concave? You need to find the second derivative first. How you find second derivative? You differentiate again. So then you get this, and then you need to let the second derivative equal to 0. You need to find the x. So when you find the x, you get the x. X is 2. So then you need to do this critical line. So then the step 2 is first find the inflection point. So my bad, sorry. You need to do the table, whether it's concave up or concave down. So when you do the table like this, okay, you do the table like I said before, the interval, you need to do the table. Okay, you need to determine either the concave up or concave down. So then the test value between the range of the critical line, and then you need to insert the test value inside the equation of the second derivative, and then you get this. You get this. So then you get this. You need to justify. You need to write which one is concave up, which one is concave down. So here. So then you need to find the inflection point. Inflection point, how do you need to find? You need to use the first derivative. Same technique like this one. How you want to find the maximum point? When you want to find maximum point, you use the function. When you want to find the inflection point, you use the first derivative equation. And then you use the x here. You use the x. You insert the x into the equation, and then done. You get this one. So my explanation here. Good luck for final. So done. Thank you.
So for the last question, we will sketch the graph of the function. So for the first step, we will list down all the important details that we get from the calculation. So first is y-intercept at 0, 0, increasing interval, 1, 2, 3, decreasing interval, negative infinity to 1, 3 to positive infinity, minimum point, at 1, -4, maximum point at 3, 0, concave up at -infinity to 2, concave down at 2 to positive infinity, inflection point at 2, -2. So right now we will draw the x-axis and y-axis. So this is y or fx, and this will be x. This will be -1, -2, -3, and last -4. Here it will be 1, 2, and 3. So this would be 0. So we can plot our points. So which is first point is y-intercept 0, 0. So here. And next is minimum point at 1, -4. 1, -4. The next is maximum point at 3, 0. So the last one is inflection point at 2, -2. So now that we have plot, now we can connect all the points to draw the graph. So it will be like this. So here is the look of the graph. So the question's done right now. Thank you for watching. As for the conclusion, we will look into tips and recommendation on solving graph of polynomial function. So for the first, find the f prime x, and second, let it equal to 0 and substitute x into f prime x to find critical point. And 3, draw the critical line. And then we can construct first derivatives table, and you can choose the correct sign, which is if more than 0, positive, meaning increasing interval. Below than 0, it means negative, which is decreasing interval. Next, 6, determine the extremum points. And 7, find double prime x and let it equal to 0, and substitute x into f double prime x to find inflection point, and again draw inflection line. Then construct second derivative table. 11, choose the correct sign, which is if more than 0, meaning positive, concave up, below than 0, meaning negative, concave down. And 12, determine the inflection point. All of these will help you construct the graph, draw the graph with the information that we get from the calculation. So that's it for the video. Thank you for watching.